Hey everyone, welcome to my new series, TitanClass. Let's go. So you're probably thinking to yourself, what's TitanClass? But more importantly, why should I watch TitanClass? Well, I'm glad you asked, and I'm glad you thought that. TitanClass is a way for you to join and watch me do problems, many problems. And you can pause me, you can ask yourself the questions, why did he do that? And then rewatch how I did it because I'm gonna work out the problems for you. In this episode of TitanClass, our very first episode of TitanClass, I'm gonna be doing factoring. Not just any kind of factoring. Factoring multiple different ways. We've got four-term factoring, factoring by GCF, factoring when A is 1, when A is greater than 1, and some other crazy stuff. I've got 50 problems for you, and I'm going to work it out right now. Part 1, four-term factoring. We've got our trusty squares here because we're going to be using the area model. So without further ado, let's get this party started. Number 1, 14k to the third power plus 2k to the second power minus 21k minus 3. Okay, certainly four terms. I'm going to plug this into my area model squares just in order how it shows. 14k to the third, 2k squared, negative 21k, and negative 3. Okay, now I'm trying to find greatest common factors so I can take stuff out, right? So it looks like I can take a 7 out of both of these, meaning factoring, and then it's got 1k. So I'm going to take a 7 and a k out. 21k squared and negative 3. I can't really take anything out here. They don't have anything in common, but because that box is empty, I still have to take something out, right? So it's going to be a 1 that comes out. That's a plus 1. 14k to the third and 2k squared. I can divide both by 2, and they both have k squared, so 2k squared is going to come out. Right. Negative 21k and negative 3. Remember the rule of thumb, when this box, or this box for that matter, runs with a negative in front, I've got to take the negative out. So I'm going to divide both or factor by negative 3 here, right? And I've got my factors, so let's see how far we can see over here. Number 1 is going to be 7k plus 1. And 2k squared minus 3. Yes, that's pretty good. Okay, let's move on to number 2. Now this process is going to be lengthy, as you can imagine. Fast forward, move it through. Don't watch every one. If you understand a certain concept, please move forward. Don't waste your time, right? Let's go to number 2. Wish these markers didn't have to get shaken. That stinks. 9n to the third power. Ooh, you can still see that. I'll erase it a little bit. Let's go down. Let's make a little arrow here so I know where to write. This is number 2. 9n to the third power minus 6n squared plus 12n minus 8. Okay, same process, right? 9n to the third. I'm going to go to a different marker in a second because that squeaking is going to annoy me. Negative 6n squared. I've got a 12n and a negative 8. Okay. 9n to the third and 12n, 3 is going to come out, right? So we've got a 3 and we've got an n because they both share an n. Negative 6n squared and negative 8. This box leads with a negative. I've got to take the negative out. I can take or factor a 2. So that's going to be a minus 2. From side to side now, I've got a 3n squared, because I can factor out the 3 from both of here. And then this one, positive number, so this is going to be a positive 2. I can divide by 4 evenly on both of them. So we've got a 4 here. Our answer for number 2 is going to be 3n minus 2 and 3n squared plus 4. Okay. Hopefully you're looking good. Hopefully you're getting these right if you're going along with me, because that is kind of the purpose of the video, right? Okay. Number 3. I'm having fun, huh? Still squeaky. 7r to the 3rd plus 28r squared minus 5r minus 20. You may be asking yourself, well, where's he looking? Well, there's this nice little table thing here that you can't see, and I've got the problems written out over here. 7r to the 3rd, 28r squared, negative 5r, negative 20. All right. No number that I can take out here evenly, but they both share an r, so an r is going to come out. I can divide both of these by 4, right? Because I can't divide by 5, and that's really all I can do with this. So 4 is going to come out. Right? Here and here, 7 is the greatest common factor because they're both divisible by 7, and then an r squared. There's sort of a pattern here with the r to the 3rd powers, right? Like we can take a square out on every one of these. And then I've got a negative that leads here. Negative's coming out, so negative 5's coming out. Done. Here we go, number 3. I've got r plus 4. And I've got 7r squared minus 5. Okay, moving on to number 4. You might be wondering why I'm putting the answers in parentheses, right? Well, that's going to be obviously really important for later. If I were to multiply those parentheses together, I would get back to the original problem at hand. Now, you may know that as foiling, multiplying binomials, whatever, it's all the same thing. So this is really important to represent the factors moving forward to our next set of problems, probably coming next week or so. And that's going to be solving quadratics. Right now we're just factoring, so one step at a time. Number 4, 5x to the 3rd minus 20x squared plus 6x minus 24. Okay. 5x to the 3rd. First box, negative 20x squared, 6x, and minus 24. Again, just like the last problem, I really can't take a number out of these two numbers, but I can pull an x out, so x is going to come out. Got a negative. This is almost actually like the last problem, because this was like a 28 and a 20, right? So let's pull out a 4 there. Here and here, I can pull a 5x squared out. And then here I can take a 6 out, right? Because they both have a 6 in common. Done deal number 4. We've got x minus 4. And we've got 5x squared plus 6. Moving on. Number 5. 4x to the 3rd plus 7x squared minus 24x minus 42. Okay. 4x to the 3rd, 7x squared, negative 24x, and negative 42. You could always put the plus signs in front if that makes it easier for you to remember. Sometimes if you forget to put the sign at all, you may think to yourself, ooh, is that supposed to be a negative? I don't usually like to do that, but sometimes you'll see me switch it up. I would just leave this as a 7x squared. Again, you could put the plus there if you wanted to, but that might seem like overkill. 4x to the 3rd and negative 24x. This is when I can pull a 4 and an x out because they're both divisible. 7 and negative 42. Well, 7 does go into 42, so we can take the 7 out. Here, I can only take an x squared out, right? Because 4 and 7 don't have anything in common. Ooh. Definitely, I could take a 2 out, right? Because they're both divisible by 2. Are they divisible by 4, though? That is. That's not going to be. What about higher numbers? 6? I can divide that by 6. I can divide that by 6 also. What about 8? Definitely can take an 8 out of that. Can't multiply or divide anything by 8 here without getting a fraction or a decimal. Looks like a 6. And it's got to be a negative 6, right? Because it's a negative in front here. Let's see if we're right. Whew. That one took a minute. So we have our factors. Number 5. Had to think a little bit about that one. 4x plus 7 and x squared minus 6. That one's tough. Moving on. Every once in a while, one's going to happen like that that pops up and has numbers or factors that are a little bit bigger, a little bit weird that you're not used to seeing. So far, we've seen pretty easy ones. That was a little challenging, right? Let's go to number 6. 9x to the third minus 12x squared minus 12x plus 16. Okay. I feel like there's a lot of 3's coming out of here. 9x to the third and negative 12x. I can definitely pull a 3 out, so let's go 3x. Here and here, 4, right? I can divide a 4 out of both. Let's pull a negative 4 out. This is going to be a 3x squared. And just like these two, these match up almost the same, right? I'm going to pull a negative 4 out of this as well. And that was weird how that happened. Number 6. 3x minus 4 and 3x squared minus 4. Very strange. Very, very strange. Okay. I feel like when I erase like this and I hold the marker, I'm doing two things at once, right? I'm not only erasing the board, but I'm also shaking the marker juice up so I don't have to worry about it later. Huh? Tell you what, sometimes you just got to think outside the box. Oop, you can't see that. Or in other words, we're going to think inside. Forget it. Forget it. 8x to the third minus 48x squared plus 7x minus 42. Okay, so we've got 8x to the third minus 48x squared plus 7x minus 42. It's a law of center. All right, no whole number can come out, so x is just going to be the greatest common factor there. Ooh. Definitely a 2, right? 4 won't, because 4 can't come out of 42. 6 can, right? Because 48 divided by 6 is 8. And 7, I can pull a 6 out of this. Can it be any bigger, though? 8, not 8. It's going to be 6. And it's going to be a minus 6, right? Negative 6. Here and here, I can divide by 8 on both of them, so 8x squared comes out. And then here and here is going to be my 7, right? I got a 7 out of both of those. So we've got our factors for number 7. We've got an x minus 6, and we've got an 8x squared plus 7. Okay. Number 8. He's actually up here barking. I don't know why. When I'm up here, he's not usually up here. Because that last time when he sneezed all over the floor and I had to vacuum it, it was unpleasant. Hey, what are you barking at, man? Huh? You barked all day. Trying to make these videos and you're barking all day long. Huh? Okay, fine. I don't care. Do what you want to do. Negative 15x squared minus 42x. I don't even know if you can hear that. It just like takes my attention away. I can take a 6 out of both. Right? I can divide by 6 on top and bottom. So it's going to be a 6x. And then it's like he barks a couple times and then stops for a minute or two and then just goes one more bark. Just one more independent bark out of nothing. 5 comes out of here, but it's got to be a negative 5, right? Here and here, I can take a 3 out of both of these numbers. I can divide by 3 on 18 and 15 and get a whole number of response or answer. So I'm going to pull a 3x squared out. And then here and here, ooh, we're getting bigger numbers. 7, right? I can divide both by 7, so we've got a negative 7. Titan, stop, bud. 8 is 6x minus 5 and 3x squared minus 7. Okay. Ooh, I didn't even realize you can't see that. Okay, let's do this. Let's do this. Okay, so this is a plus 7 and a minus 7. Let's see how we can get here. Plus 7, minus 7. Okay. 3x squared minus 4. Why didn't you tell me that you couldn't see it? 3x squared minus 4. It's better, right? And then it looks like there's only one more you can't see. This is a plus 6 here. 5x squared plus 6. I'll move these over from now on. 5x squared plus 6. You can see the rest. All right, there we go. Okay. All right, so that was number 8. We got a number 8 done. Hey, buddy, what are you barking at? You all right? You're out of breath. Just chilling out of breath. Okay, whatever. 9. 5m to the third. That's a 5, sorry. Plus 40m squared. Plus 2m. Plus 16. Hey, you're really out of breath. You all right? Oh, yeah, you're chilling. That's good. All right, 5m to the third. Now he's laying over there. He must know I'm only on number 9. Got 41 to go, brother. Huh? Okay. No number can come out, but the m can come out. 40m squared and 16. That's an 8. I was going to say 4. That's an 8. I can divide both by 8. So just be aware, right? Sometimes, like 4 jumped out to me right away, but that's not the greatest common factor. I'm looking for the greatest number. So that was a little tricky. Here's going to be my 5m squared. And then this is just 2. All right, I'm going to make sure that you can see this time, right? So 9 is m plus 8 and 5m squared plus 2. That's nice. Okay. After 10, I'll erase and go forward with other stuff. Okay. 3k. Ooh, hello. 3k to the third, 5k squared, 15k, and 25. All right. 3k, 5. That one's not bad. Just k squared. I can't pull anything out with the numbers. 5, right? There we go. 3k plus 5. And k squared plus 5. All right, take a minute to write those down if you want to, or take a picture of them. I'm going to go ahead and erase them because I don't want to keep a running tally because I really don't know. I'm not comfortable with how far this goes down. And then we'll restart with 11. Now, I think most of you out there are saying to yourself, hey, well, why don't you just edit the video so I don't have to keep watching you erase? It's a good thought. I'm not doing that. I'm not doing that. That'll take forever. It will literally take forever. All right, we're on number 11. Don't forget, right? Tell me. Make sure you tell me that we're on number 11. Titan, what number are we on? Thanks. Number 11. Okay. I actually want to make this here so I can see it. Okay. 15x to the third minus 25x squared plus 3x minus 5. I only have one more after this of this set of 4-term factoring, and we'll go to something different. So this video is not all of 4 terms. 3x comes out. Negative 5. 5x squared, right? Interesting. Nothing. I can't take anything out. But when you think nothing to yourself, it's 1. I have to have something here. All right? That was me barking. That was me barking. That was me banging on the window, Belle. Now you're just barking for no reason. You know that was me. I actually think he wants to be seen and heard by all of you. That's what I think. Because he knows better. He's actually pretty bright. I think. Last one on 4-term factoring, then we'll jump to something else. All right? That arrow's terrible. Get out of here. Okay. Number 12. 5m to the third minus 8m squared minus 15m plus 24. Okay. 5m to the third minus 8m squared minus 15m plus 24. 5m, right? -8 can come out of both, yeah? M squared only. The 5 and the 8 don't have anything in common. -3. That's hard. They're both divisible by 3, right? Because 5 times 3 is 15, and 8 times 3 is 24. So -5 is going to come out. All right. I really think that's going to be the biggest struggle that you guys see, is sometimes you're going to find that the factor doesn't come up, like the greatest common factor number value doesn't just pop in your head very quickly. And that's okay, that happens, right? That happened to me a couple times here just today. So just give yourself a minute to think it through. There's no real speed here in terms of really getting it and saying, man, I really need to get this in the next 2 seconds. Give yourself a chance to think, right? Okay, so those 12 problems were 4-term factoring. Let's jump to another set. Factoring when a is 1. Okay, now, when a is 1, what I mean by that is the first term, its initial value or its first coefficient, we call that a leading coefficient. There is no number there. When that number value is not there, it's 1. So you're going to see things in a minute what we're talking about. So let's jump right to number 13. 13 is going to be m squared minus 8m plus 12. So we got a lot of differences here from these sets of problems that we're going to do from the previous ones we did, right? So I've got 3 terms now, not 4. Initial value is 1, meaning the initial term, meaning a, is 1. And I can't really make any rhyme or reason about it in terms of getting 2 sets of factors. So we're still going to use our area model with our boxes here. Same idea. The first box I see is going to be that first term with its highest exponent. The last term, if you remember, is going to go in this bottom right-hand corner box. These 2 empty boxes is what we kind of have to figure out. Now, what we're going to be doing here is I'm going to take this 12. Normally, I would multiply it by whatever this number was in front, but because it's just 1, 12 times 1 is just 12. I'm trying to find factors of 12 that could add or subtract to get -8. Now, this part I'm going to go a little longer on for these first few. 1 times 12 is 12, no doubt. 2 times 6 is 12, and the other factor pair is 3 times 4. Now, we need to pick which one of these 3 could I manipulate with plus or minus signs, or 2 pluses or 2 minuses, to add to -8 or subtract to -8. And that 2 and 6 is going to be what I want the whole way here. Now, what do the signs have to be? Well, if I'm trying to add or subtract to get a -8, both of those signs must be a minus sign or a negative sign. So I need a -2 and a -6. It doesn't matter what order I put them in. I'm just going to put the -2 here because that's the first number that I had, and I'll put the -6 here. Last step before we start greatest common factoring is those 2 numbers have to get that letter behind it as well. So I'm going to put the m because that's what we're using obviously here. Now we can play the same game as what we've done for the first 12 problems. Take the greatest common factor out and move it along. Here, the only thing I can take out of both of these is an m, right? 1, so m comes out. Here, again, same rule applies. When one of these boxes or both of these boxes are negatives, negative comes out. -6 is my greatest common factor there. Here is just an m, and here is a -2. Now, when we talk about when a is 1, you are always going to have just that letter and that letter in 1s, period, no more. And the reason for that is because there wasn't a number here in the first place. So why would we have a number in front of this m or that m anyway? We have our factor pairs. We've got an m minus 6, and we've got an m minus 2. Done deal. All right? So these next sets of problems, I don't really know how many there are going to be just like this. 14. V squared plus 5v minus 24. Okay? V squared is going to go in my first box. -24. Just making sure that was a -24. Goes here. Now I'm looking for factors of -24 that I could use to add or subtract to 5, right? The middle term. 1 times 24, I'm going to ignore the negative sign for now because it's still going to work out in our favor regardless of that sign. 2 and 12, 3 and 8, 4 and 6. Obviously 5 won't work. And then if I were to get back to 6, I'm not going to write 6 and 4 again because I'm not duplicating that. Now which set is going to work for me here? 3 and 8. Because I can do 8 minus 3 to get 5. So if I want 8 minus 3, the negative sign's got to go on the 3 and the positive sign's got to go on the 8. So I'm going to put a negative 3 here and my positive 8 here. And V was the letter we were using. So here it's going to be V like I had said last time. And here it's going to be 8. It doesn't matter if that's negative. This isn't. So it's going to be a positive. V is the only common factor here. Negative 3. And our factors are set. 14 is going to be V plus 8 and V minus 3. All right? Hopefully you're following along or you tuned into the pieces that you really wanted. That's Titan class. I do the problems, you check them, you do them with me, and you move it along. 15. Okay. A is still 1 here, so I didn't trick you. Let's see what we got. I know what you're thinking to yourself. How could you? It wasn't me, it was the paper. I'm sorry. We have a problem here. It's not really a problem, it's a little problem. A is definitely 1, but there's no third term here. Now, when this happens, I'm not a huge fan of using the area model. I don't really know if I could use the area model here. So we're going to go a little old school. Instead of plugging this into the area model, we're just going to use these two terms like they were here anyway, right? What's the greatest common factor of both those terms? What can I take out of both? And the answer is X. Now, I like to put that in parentheses alone, and there's a reason for that that we'll get to at another point. When I divide an X, or when I take out an X from both of these terms, we have to set up another set of parentheses to find out what was left over. So when I take X out of X squared, 1X remains. When I take X out of 7X, or positive 7X, or plus 7X, the plus 7 remains. Those are my factors. So number 15, when A is 1, I didn't really trick you. I did. It's okay. These are my factors. It's just like I'm filling in only 2 boxes and then pulling stuff out. That's really all it looks like, okay? You're going to see a few of these. And they are very important, obviously, because they're factoring 2-term or factoring binomials. That was 15. Let's go to 16. Back to some normalcy. M squared minus 18m plus 80. Okay. M squared, 80. I'm looking for numbers that I can multiply to get to 80 that I could use to add or subtract to negative 18. So, there's a lot of factors here. 1 times 80, 2 times 40, 3 doesn't fit, 4 times 20, 5 times 16, 6 doesn't work, 7 doesn't work, 8 and 10, 9 doesn't work, and then I would go back to 10. So which one of these 5 is what I'm looking for to get to a negative 18 with adding or subtracting? And it's going to be 8 and 10, right? Because nothing else will work. Sometimes you're going to be crossing stuff out. Like, for example, I couldn't make a plus or minus sign with 1 and 80 to get negative 18 in any circumstance. Like, if I both added them, it'd be 81. If I subtracted them, like 80 minus 1, it'd be 79. I'm nowhere near 18, right? So we can't do that. So we'll use 8 and 10. They're both going to be minus signs. Negative 8m, negative 10m, and then we'll go from there. M comes out, negative 10. M, negative 8. There we go. Number 16, m minus 10, m minus 8. Looking good. Number 17 coming at you. K squared minus 11k plus 18. This one's not too bad. I know I need a 9 and a 2. And they both have to be minus signs. Okay? Okay. Done deal. All right, we're flying now. 18. I tried using water to help me with this process. Bad mistake. Big mistake. That was a really big mistake. Because this is glass. You need actually like Windex, but you can't use Windex because Windex leaves that kind of streaky stuff behind. You need like this special glass cleaner. It's very special. Okay. Weird problem. That's a 1. That's there. That's a 1, right? Just like the first term, when a is 1, you don't see it. We don't have to write 1 in front of a variable because 1n is the same as n, right? It's just there's just 1 there. So the 1n is going to be what I'm looking for, so it's going to be a 1. I need a 9 times 10 here because 10 minus 9 is 1. So a positive 10 and a minus 9. That could have been a little tricky. Let's do it. N, 10, n, negative 9. Now again, it would have worked either way if you put the 10n here and the negative 9n here. It doesn't matter either way, right? Because you're going to end up with the same factors. Now, the question is, if you had the negative 9 here and the 10n here, how would this change? Well, you would have just had n minus 9 here instead of here. And you would have had n plus 10 here, right? That's all it changes. Because the order of these things don't matter, right? How I'm writing them here, it doesn't matter either way. Because they're still multiplying. Let's go to 19. And again, I'll just go to 20 here in the next 10, and then I'll erase, and then we'll move on. B squared minus 5b minus 24. We did one like this earlier. Titan, where are you, dude? You're not there anymore. That's bad. Negative 5. 3 and the 8, right? Yeah. 3 times 8. I need the bigger number to be negative though here because my answer is going to result in a negative. So the negative has to be on the 8 and the positive on the 3. So we'll do 3b and we'll do a negative 8b here. All right. So b, negative 8, b, 3. Okay. Last one for the set of 10. I think we still have a few more like this though. K squared minus k minus 56. Okay. Minus 56. Okay. Just like a previous one we did. What was 18, right? That's a negative 1, right? Because we don't have a number, but it's a negative sign in front, so it's a negative 1. Be careful. Changing that sign up will screw up this whole problem. 7 and 8, right? I need a 7 times an 8 because I can do negative 8 plus 7, which will give me a negative 1. Negative 8 plus 7, so we'll do a 7k and a negative 8k. K comes out. Negative 8, k, 7, factors. K minus 8, k plus 7. Nice. All right, so we'll jump to 21. I'll erase this set of 10. Nearing the halfway mark. We're getting there, huh? Hope you're learning something. I know what you're thinking to yourself. How are you doing these so fast? How do you know the factors so fast? I teach math. I'm supposed to be faster than you. I'm supposed to be. Now, that's not always the case, right? Sometimes you're faster than me. And it wouldn't surprise me at all if I made a mistake. So, it happens. Number 21. N squared minus 6n plus 5. Obviously, we're still using our area model. N squared 5. 5 for negative 6. Ooh, this is a tough one. Why is it a tough one? Well, get the signs wrong. I don't ever like these ones. I don't like ones that have 5s and 6s in them, like just 5s and 6s. Some of you know what I'm talking about. And if you don't, that's okay. Forget I was talking. 5 and 1 are the only thing I can use here. Now, they both have to be negative, and that's what I'm talking about, kind of. That's like messy, because whenever we have a 1 involved, it gets things to be really ugly. Negative 5n, negative 1n. Now, I would write the 1 here just to help me understand, because negative n would look weird if you were trying to take something out. Here and here's an n. Negative 1, n, negative 5. Ugh, I don't like those ones. 21. I'll come over a little bit. N minus 1 and n minus 5. Okay. Okay, one more and we're done with the set. And then we'll move to something else. Okay. 22. And again, this is kind of like one of those tricky ones. This is going to be a 2-termer, x squared minus 8x. Nothing else behind it. Still have a as 1 though. Not going to use the area model. What do both these things have in common that I can take out, factor out? And they both have an x, right? So I'm going to take the x out, put that in parentheses by itself. What's left over? When I take x out of x squared, x is left. When I take x out of negative 8x, negative 8 remains. Done deal. That's my factors. 22 is going to be x and x minus 8. All right. What is the next set, which starts at 23? Uh-oh. Factoring when a is greater than 1. Okay, so same process, 3 terms, but the initial value, the leading coefficient, what we call it, is greater than 1. Number 23 is 2x squared minus 3x minus 5. Same process. The exponent of 2, that term goes in my first box. The last term, which is the constant value, goes in the bottom box. Now, you may remember me saying a couple of minutes ago or 10 minutes ago, or I don't even know how long we've been doing this video, is I always write this number down, the last number here, and try to find factors of it to find the middle term. We would be normally multiplying that by this number anyway. But in previous problems, when a was equal to 1, it was just 1 anyway. So in this case, it would have been negative 5 times 1, which is negative 5. However, because there's actually a number here, a value that's not 1, greater than 1, I am going to be multiplying these together to get the number I'm trying to find factors of. So 2 times negative 5 is negative 10. I multiply always when it looks like this, that first value, the leading coefficient, and the constant. Now, I'm trying to find factors of negative 10 that I could use to add or subtract to negative 3. Well, the only factors of 10 are 1 and 10 and 2 and 5. I know I obviously need the 2 and the 5, and the 5, the bigger number, has to be negative because my result is negative, right? So that's a negative 5 and a positive 3. So we're going to have 2x and negative 5x here, okay? So we'll do multiple problems like this just so we can get the flow. 2x is going to come out here. Negative 5. This is a weird one. X. 1. Nothing in common. 1 comes out. All right. Got our factors for number 23. And that's going to be 2x minus 5 and x plus 1. All right. So a little bit more work on our part, but to be honest with you, it's not that much more work. It's just multiplying the a term and what we call the c term. C for constant. All right, 24. Almost halfway there, guys. We're getting there. Ooh. We'll skip that one. It'll still be 24. 3x squared plus 4x minus 7. 3x squared minus 7. To fill in these two boxes, I have to multiply the 3 and the negative 7 together to give me negative 21. That's what I'm trying to find factors of to add or subtract the positive 4. So 3 and 7. But because I want a positive 4, the 3 has to be negative. The smaller number has to be negative, and this is a plus 7. Okay. So negative 3x. It's just coincidence that's happening like this. I did not set it up like this. It was like the last problem, how we had the same number, or the same exact value, and the same value. So 3x comes out again, which is very strange. I feel like we did the same problem twice. 7x. Negative 1, tricky. No number value, no x comes out, but the negative leads. Negative has to come out and a 1. This is a good problem. 24 is 3x minus, 3x plus 7 and x minus 1. That's a good problem. 25. As soon as we're done with this, we're halfway done. We can call it halfway done. We can't. It's not really halfway done. All right, 25. We have a little bit of a trick here. Again, it wasn't my intention. It just kind of happened that way. Two terms. A is still greater than 1, though. So anytime we have a two-term or a binomial, we're just going to look and see what I can factor out evenly. Well, I can't factor any numbers out, but they both have a p in common. So 1p is going to come out. And then my next set of parentheses is just going to be what's left over. Well, if I take a p out of 3p squared, 3p remains. And if I take a p out of negative 5p, the negative 5 remains. Factors, done. You may be like, that's way easier than anything else we've done. That's fair, right? It's probably right. But they're tricky, or they can be. Halfway done. The dog's probably chewing something apart downstairs. I hope not. 26. Ooh. I don't know why I'm laughing. That wasn't really funny. 7x squared minus 2x. What do they have in common? An x. What's left? 7x is left. Because remember the square, that means there's two x's there. This really says 7 times x times x. We don't write x times x, though, out loud, because, or on paper, because that doesn't make sense. So we put the square there because that's what exponents are, right? Exponents is like the simplification of multiple of that same thing happening in multiplication terms. Like I wouldn't write 7 times 7 times 7 out. I would do 7 to the third power. Fun. Minus 2. Done. Okay, let's move it along. 27. Seven x squared. I think this is when the numbers get really big. Minus 26x minus 8. That's thunder. Wow. 7x squared. That's not the dog. That's actually thunder. Minus 8. If that was the dog, I'd be really nervous. 7 times negative 8 is negative 56. That's not really the dog, is it? Minus 26. Could be bad. Okay, this is a stinky one. Let's write the factors out. 1 and 56. 2 and 28. You know, sometimes you're going to be writing the factors out and you're going to do just what I did right now. You're going to stop because you realize that you got it. How weird. So I've got a negative 28 and a positive 2. We just ran into that one. So let's go 2x and negative 28x. Okay. X comes out. 8 won't come out of negative 28, but 4 will. All right, so negative 4. Is that right? Hopefully that's right. 7x, 2. All right. Once you get in the flow, right? I mean, once you get in the flow of factoring, a lot of this stuff is going to become second nature to you. Be quicker to think about them. 28, 7k squared plus 12k plus 5. Okay. Seven times 5 is 35. 12. I need a 7 and a 5. 7 times 5 is 35, and 7 plus 5 is 12. I feel like this is the first one that we had both pluses in a while, or at all. 7k and 5k. 7k comes out. 5. Just k. 1. So we have a 7k plus 5 and a k plus 1. All right. 29. Two x squared plus 9x minus 5. 2x squared goes in the top box. Oof. Minus 5. 2 times negative 5 is negative 10. And I'm looking for factors of negative 10 that I could add to 9. I need a 10 and a 1. And the 10 has to be positive, and the 1 has to be minus. 10 minus 1 is 9, right? So we've got a 10x, and we've got a negative 1x. And again, I'm going to put the negative 1 just for my own sake to make it a little easier, because sometimes it's hard to say, well, what's the greatest common factor between negative x and negative 5? You know, I could take the negative out, but negative what? And that might make a little bit more sense if there's a 1 there. All right. 2x comes out. Negative 1. X. 5. Right, because that's not negative. That has to be, this is supposed to be outside, this is supposed to be outside. I apologize. 29. 2x minus 1, x plus 5. Rolling. One more, and then I'll erase the set to my right, which actually is your right. Huh. Right? Maybe not. 2x squared. Oh, ew. Come on, marker. Get it together. Minus 5x plus 3. 2x squared. See, if it was more to the left, this little, I wouldn't have wrote in. Okay. You don't care. It's fine. 6. 6 and a 5. Okay. Okay. Problem. It's not really a problem. It's just annoying, this problem. 1 times 6 and 2 times 3. Right? Both of these, I could manipulate both of these to add to a negative 5. Right? Because I could do positive 1 or plus 1 minus 6, which is negative 5. And I could do negative 2 minus 3, which is also negative 5. Okay. How do we know? Well, remember that whatever pair you pick has to multiply to get positive 6. Right? So if I did positive 1 and negative 6, that certainly gives me negative 5 with adding or subtracting. But positive 1 times negative 6 is not positive 6. See what I mean? Do you see what I mean with these problems? This one particularly is terrible, huh? Negative 2 and negative 3. Okay, so we've got a negative 2x and we've got a negative 3x. When I saw this on the paper, I was like, oh, I know this is going to be a problem. 2x, so we got through it together, huh? No, negative 3, not no, negative 3. X, negative 1. This problem has been terrible from the beginning. 30, I'm glad it's done. 2x minus 3 and x minus 1. What a crappy problem. All right, 30 down, 20 to go. Whew. All right, so we'll do a 31 over here. Let's go ahead and erase this stuff. All right. 31. We're still in the same pair or set of factoring when a is greater than 1. So let's just continue the process here. I think I got a few more like this, and then we'll move on to another set. 3x squared plus 7x minus 6. Okay. So we've got a 3x squared. We've got a minus 6. 3 times negative 6 is negative 18 for 7. 9 and 2. Positive 9, negative 2. Right? Because positive 9 minus 2 is 7, and positive 9 times negative 2 gets me back to negative 18. So we've got a 9x and a negative 2x, 3x. Negative 2, x, 3. It was good that I did that last time. 31, 3x minus 2, and x plus 3. All right. $32. 7n squared minus 33n minus 10. 7n squared minus 10. 7 times negative 10 is negative 70, and I'm trying to get a negative 33. Okay, these are big numbers. Let's do some factor pairs. You know 1 times 70 is 70. 2 will fit, and 2 times 35 is 70. And again, just like the last time we tried this, we ran right into the factor pair that we need because I can manipulate a 2 and a 35 to do this. This might be the best way to find factor pairs if your calculator isn't available. It got up, ran away, whatever. You're just going to go down the list of numbers, obviously. You know that 1 times whatever that number is, that number, right? Then go directly to 2 and then see what you can do by dividing. I would have gone to 3, and I know 3 doesn't fit. Now, if you don't know, I'm sure you have a phone, you can use a calculator there. 4, 5, 6, 7, and so on, right? That's probably one of the best ways, besides using the calculator function, to get what you need, okay? I know I need a plus 2 and a minus 35 because I have to add to get negative 33. So this is going to be a 2n and a negative 35n, right? N, negative 5. 7n, 2. N minus 5, 7n plus 2, okay? All right. Let's see what the next set of problems is going to be for us, everyone. Oh, my favorite. Factoring by GCF. Now, we've already kind of done factoring by GCF a little bit when we had the 2 terms going back and forth. Now, we're going to see a few more like that, right? But I want to introduce something that may be a little bit different. Obviously, you saw that the boxes got scared and ran away. So we don't need them at this moment in time. Let's try a few together. Number 33. 6xy plus 24xz minus 12xw. Huh? Well, it's not quadratic because we don't have a 2 exponent anywhere here. But all 3 of these terms do or does have something in common. They have multiple things in common. So let's figure out what they have in common and then take it out. Let's look at the numbers first. 6, 24, and negative 12, they all have a number that we can divide evenly out of them. And the greatest common factor of all of those numbers is 6. So let's take a 6 out of all of them. What else do these 3 terms have in common? Well, clearly they all have letters, but each of these 3 terms has an x. That means I'm able to take that x out. So let's do that. And before we kind of finalize that parentheses, just double check to make sure there's nothing we can pull out. And there isn't. So 6x is our greatest common factor of those 3 terms. Now, let's go ahead and write what's left. If I take a 6x out of 6xy, y remains. If I take a 6x out of 24xz, well, let's do the numbers first. Dividing 6 out of 24 leaves me with 4, and the plus sign drops. But the x came out, so what's the only letter left? Z. Minus sign, because that we didn't take a negative out. When I divide that 6 out of 12, I get 2. Remember, the x came out, so w remains. Final answer. Strange, but final answer. So we've got 6x, y plus 4z minus 2w. All right? So again, greatest common factoring, a little more high level, right? Because it's got a couple different terms. We got a whole bunch of different variables in there, but it doesn't matter. Factoring just means divide out what they have in common, period. All right, let's go to 34. You'll get into a groove on these pretty quick, I think. 40RS minus 80R. Now, sidebar, remember a couple things about combining like terms. I am not able to subtract these two things. Clearly, I could have done 40 minus 80, but there's an RS attached to the 40, and there's an R attached to the 80. They are not like terms. For these to have been like terms, there would have had to have been S there, but there's not. So we're going to forget that conversation ever happened. Moving on. I am going to find out the number I can pull out evenly, or divide, or factor. They both have a 40 in common, so I'm taking a 40 out. They also have an R in common. That's the greatest common factor. What's left though? Well, when I divide 40 out of 40, I get 1. Now, I'm not going to write the 1 unless the 1 is alone, meaning there would be no letter I could take out. But the R came out already, and the S has to stay. I don't have to write 1S. If it makes you feel better, go for it. But 1S and S is the same thing. Just means 1S. So I'm just going to take the S and leave it there. Minus sign, when I take a 40 and divide it out of 80, I get 2. But the R came out. Done deal. Now, if I were to multiply these back together, like distributive property, which is, by the way, the reverse of factoring, huge concept. I can't believe we never talked about that before. Factoring is the reverse, or inverse, of distributive property. We're multiplying. We say multiply a lot, but it is actually the distributive property. Please remember that. Hopefully you tuned into this part of the video where I said that. I don't know what time it is. I'm tired. 34. 40R. S minus 2. 35. We're getting there. We're going to get there soon, hopefully. All right, 16xy plus 34z. Okay, now, much different than the first two problems on this section that we saw. There are no variables in common here, right? That's an xy and that's a z. So when you take your greatest common factor out, there should be no variables there. They do have something in common with the numbers though. And my greatest common factor of both these numbers is 2, believe it or not. I can't go to 4 because 34 is not divisible by 4. And I can't go to 8 because 8 doesn't work into 34 either. So 2 is the lone greatest common factor. Now we can just divide out and finish up our problem here. 8xy plus 17z. Done deal there. And again, you have calculators. Please use them. Please don't be afraid of them. But more importantly, please don't be ashamed to use it. That's what calculators are for. They're for the helping of the process of operations that might have had a hard time otherwise to get done. Like for example, when you're tired, like me right now, you may need the calculator to say, oh, I just need the calculator to do this calculation so I can move on to some more things. As you get into higher level mathematics, that's going to happen more often, believe it or not. 36. (4z) plus 16y minus 2x. Very similar to a previous problem. Z, y, and x. No variable in common, so no variable should be taken out. But they do have a 2 in common that I can take out. So let's take a 2 out. Now you might be wondering to yourself, how come I don't take the negative out? Well, I don't like to take the negative out unless I absolutely have to. If they were all negative signs, maybe. It really depends on what the context of the problem is. Since we're just doing GCF, I don't have to take the negative out. So let's just keep it like that for now. 2 comes out, 2z, 8y, negative x, negative 1x, right? Because I took a 2 away, but the minus sign stays. I didn't divide by negative, and the x stays. So we have our answer for 36. And it is 2 times 2z plus 8y minus x. Okay? 37. Mm, 18a plus 16b minus 9c. You're seeing the pattern of the letters here. A, B, and C, they're not in common in any way. So let's see what number we can take out of Eve. 3? Huh. I can take a 3 out of these two, but I can't take a 3 out of that. 2, let's try that. 2 can come out of 18. 2 can come out of 16. Huh. But I can't take a 2 out of a 9. This is a real head scratcher. Is there anything that I can take out of this? Is there anything factorable in this expression? No. So what's the answer? It stays the same. That is the answer. 18a plus 16b minus 9c. Sometimes you're not going to have anything to factor out. That is rare, because obviously we're doing factoring. But every once in a while, you're going to come up to something that is not factorable. We'll get into that later on. 38. 100x minus 100y. If you're saying to yourself, wow, it's 100. Good job. It is 100. 100 comes out, but there's an x and a y left over. They're not in common, so I'm going to leave that x and the y inside the parentheses. So for 38, we've got 100 and x minus y. 39. X plus y minus 3z. X, y, z. No variable in common. 1, 1, negative 3. So the question is, how come I don't take a 1 out and put it in parentheses? Well, I don't have to do that ever. And the reason is the same as we know this is 1x and this is 1y. I don't have to rewrite that 1. I don't have to rewrite it by taking it out or factoring it out when it's alone. Now, if there was something else there, great. Just like the reverse. If I was to take something out by dividing and it was the same amount or the same thing, I'd have to write the 1 there to represent it. So the reverse is true when I'm factoring. I don't have to write the 1 if it's by itself. So just like the previous problem in 37, 39 is going to be exactly what we were given. X plus y minus 3z. And there is something to say again about sometimes things just are not factorable. 40. And this is the last in this set. 2ab plus 4ac minus 8ad. Definitely can take a 2 out, right? Because 2 is a factor of all these numbers. And like one of our beginning problems, all 3 of these terms have an a. So the 2a comes out, which is going to leave me with a b, a 2, and a c, minus sign 4, right? Because I'm dividing. 8 divided by 2 is 4. And the a came out, which is leaving me with d. So our answer for number 40 is going to be 2a, b plus 2c minus 4d. Looking good. All right, our last 10 problems. Let's go ahead and erase this. And let's see what we have on the docket for the last 10. Looks like we have a little bit of a mixture. We're going to have to pick and choose here. That stinks. Number 41. Two n squared plus 5n. What should I do? It's a binomial. GCF all the way. N comes out, I'm left with 2n plus 5. I don't like having to guess, right? That's weird and hard. 5b squared minus 8b minus 21. 5 times negative 21 is negative 105. For negative 8, ooh, that's a bad one. All right, let's do it. 1 times 105, 2 doesn't fit. Does 3 fit? 105 divided by 3 is 35. Nowhere near. All right, we have to keep going. 4 doesn't work. Let's see if 5 works. 5 and 21, nowhere near. I don't think 6 works. It doesn't. Let's try 7. 7 and 15. We got it. So I need a negative 15 and a positive 7. Let's go. B. Negative 3. 5. 7. 5b. 42. B minus 3. And 5b plus 7. The picking and the choosing makes it really hard. 43. 5x squared minus 7x. GCF. X comes out. 5x minus 7 remains. Now we're flying. Only a few left. 5x minus 7. Okay. 44. 2n squared minus 19n plus 42. A is greater than 1. Let's do it. 42. 2 times 42 is 84 for negative 19. 1 times 84. 2 times 42. Does 3 fit? 3 and 28, we're getting closer. 4 will definitely fit. What's 4 divided by, what's 84 divided by 4? 21. Ooh. No, not there yet. 5 doesn't work. Does 6 work? 6 and 14? Ooh. Nope. Wow. 7, huh? It's got to be 7. 7 and 12. Be honest with you, I got nervous. I got nervous there for a second. Because if it wasn't 7, I know it wasn't 8, and I know it wasn't 9. I didn't want to make a mistake. I'm glad I didn't. But you know what? We all make mistakes. I just didn't want to make one right now. So I got a negative 7 and a negative 12 because I have to add to negative 19. Negative 7n and negative 12n. N comes out. Negative, ooh. Negative 6. 2n. Negative 7. N minus 6. 2n minus 7. $45. This one's going to be terrible. 7m minus 65m plus 72. Ugh. Oh. 7m squared, 72. Ugh, this is awful. 7 times 72 is 504 for negative 65. Okay, I'm going to use the calculator for this one. So what we like to do, hit the y equals button, and I'm going to go 504 divided by x, and then second graph. And it's going to bring up a couple of little graphs here. I know you can't see that. I don't know why I'm showing you. I'll make a separate video about how to do this functionality. So I'm looking for a pair of factors of 504 that I could get to negative 65. 9 times 56. And they both have to be minus. So negative 9m, negative 56m. So the question is, how many times am I going to see this like in real life? Virtually never. So when we talk about huge numbers like this, it is extremely rare, number one, you would see this, and number two, there are functions to use to help us solve these types of things, right? M comes out here, because I can't come anything with a 7 or -9. I'm thinking a -8, right? Because I can divide -8 out of both of those. I'm just wondering if it's anything bigger. I don't think so. 7, M, -9. That looks right. 45 is M minus 8 and 7M minus 9. Okay. (46) 3n squared minus 7n minus 6. I put that way too close over there. Sometimes it's hard to see. (-18), (-7), 9 and 2. We've done one of these before. (-9), +2, (-9n), 2n. 3n comes out, 2. N, (-3). 46. 3n plus 2, n minus 3. 3r squared minus 10r. GCF. (3r minus 10 and r). A couple more. 48. 7n squared minus 3n. GCF. N comes out, only thing in common. 7n minus 3. Okay. 49. Y squared plus y. GCF, y comes out. Y is left plus 1. Have to put a 1 here because y divided by y is 1. 2 terms here, I need 2 terms in here. Final problem of this marathon. X squared, number 50, plus 6x plus 9. A is 1, so I need factoring when A is 1. X squared, 9. 9 to get 6. 3 times 3, and they're both plus. 3. Huh. Now that was a marathon. I hope you got something out of this. If you watched the entire thing, that's amazing. Thank you. But really, you're welcome. Because I wanted to help you understand this a little bit better. I know factoring can get really tedious over time. Thanks for tuning in to Titan Class. We'll see you next time.